Hey guys, today we're looking at 2.9, which is going to talk about some tangent lines. So for number one, the first thing we need to do is graph our function right here. So what I did is I created a list of points or a table over here on the side. And so I used -4, -3, -2, -1, 0, and 1. And so I got -4, 3, -3, -1, -2, -3, -1, -3, 0, -1, and 1, 3. So I'm going to come over here and graph all of these. So I've got -4 of 1, 2, 3. And then I've got -3, -1, -2, -1, 2, 3. -1, -3, 0, -1, and 1, 3. So I've got my parabola right here. Yeah, I actually do that one pretty well. So the next thing, part A says find our derivative. So if I have f of x is equal to my x squared plus 3x minus 1, my derivative, f prime of x, is equal to 2x plus 3. So part B, where it says find the slope of f of x at x equals -1, that means I'm going to find my derivative at -1. So I'm looking at 2 times -1 plus 3, or -2 plus 3, which gives me a 1. So what I'm looking at here for part C is my tangent line at x equals -1. So I know at -1 it's going to go through this point right here, and then I just found that the slope was 1, so it's going to go up 1 over 1, up 1 over 1. And so my tangent line is going to look like this. Ooh, let's try that again. It's going to look like this, and I'll extend it over here as well. There we go. There's my tangent line. So now we need to find the equation for the tangent line. And how I'm going to find my equation is I'm going to use y minus y1 is equal to m times x minus x1. So right here is my m. Right here is my x1. And so all I need to do is plug that into my original function. So f of -1 to find my y1. So I'm looking at -1 squared plus 3 times -1 minus 1. Or I can look over here at my table of values and see that my -1 gives me a -3 for my x1, y1. So I'm going to have y minus a -3 is going to give me plus 3 is equal to m, which is 1, times x minus my -1 right here, which is going to give me plus 1. So I've got y plus 3 is equal to this right here. So I've got y plus 3 is equal to x plus 1. And then I'm just going to subtract 3 from both sides. So y is equal to x minus 2. And there's the equation for my tangent line. So you can leave it in either of these two forms right here, or even like that right there. You don't always have to get it down to y equals. So from here on out, I'm just going to leave it in this form right here, my point slope form. And let's look at number 2. So my function right here is f of x is equal to 3 square root of x. So let's graph that. I know my square root of x normally goes over 1 up 1, but we have 3, so I'm going to go over 1 up 1, 2, 3. It's got a vertical stretch by 3. So over 1, 2, 3, 4, and instead of up 2, I'm going to go up 6. 1, 2, 3, 4, 5, 6. And over 9, instead of going up 3, I'm going to go up to 9. So here's what my function looks like. And then it says find the derivative. So the first thing is that we can rewrite this as f of x is equal to 3x to the 1/2. So when I find my derivative, f prime of x is going to equal, well, 1/2 times 3 is going to give me 3/2. X, well, 1/2 minus 1 is a -1/2, which is equal to 3 over 2x to the 1/2, or 3 over 2 square root of x. And now we're going to find the slope at x equals 4. So that means I'm finding my derivative at 4. So 3 over 2 square root of 4. So 3 over 2 times 2, which gives me 3 over 4. And let's graph our tangent line at 4. So over here at 4, I'm up at this point right here. So my point is 4, 6, right? And my slope is 3/4. So I'm going to go up 1, 2, 3 over 1, 2, 3, 4. And I don't have any more room to the right, so I'm going to go to the left, which would be down 1, 2, 3, and 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So my tangent line is going to kind of look like this. So to find my equation for my tangent line, I'm going to be looking at my y minus y1 is equal to m times x minus x1. Well, here's my x1 and y1. Right here is my m, the 3/4. So I'm looking at y minus 6 is equal to 3/4 times x minus 4. All right, let's look at number 3. So this time we're looking at our rational parent function, our 1 over x. So remember that that goes through these 2 points here and makes this shape right here, this curve. And this curve. Sorry guys, my drawings are really bad. There's a reason I'm a math teacher and not an art teacher. All right, and then I'm also going to rewrite this as f of x is equal to x to the negative 1 power. So when I take my derivative, f prime of x, that negative 1 is going to come down in front, so negative 1x. And negative 1 minus 1 is going to give me a negative 2. So negative 1x to the negative 2. And cleaning that up, that's negative 1 over x squared. So to find the slope at x equals negative 1, I'm taking my derivative at negative 1. So that's negative 1 over negative 1 squared. So negative 1 over a positive 1, which just gives me negative 1. And we're looking at this point right here, negative 1. So that means our point is negative 1, negative 1. And my slope is negative 1. That's a lot of negative 1s. So it's going to go down 1 over 1, down 1 over 1. It's going to make this pattern right here. So when I draw my tangent line, it's going to look like that. And I can extend it over here as well. So now we need to find my equation. So I'm looking at my y minus y1 is equal to m times x minus x1. Well, here's my x1, here's my y1, here's my m. So y minus a negative 1 is going to give me plus 1 is equal to a negative 1 times x minus a negative 1 gives me plus 1. So y plus 1 is equal to negative 1 times x plus 1. And example 4. So it says, let f be the function defined by f of x is equal to 4x cubed minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of f at the point where x is equal to negative 1? So if I'm looking at where x is equal to negative 1, I need an x1, y1, and an m. Well, x1 is negative 1. y1 is when I plug negative 1 in there, so 4 times negative 1 cubed minus 5 times negative 1 plus 3, or negative 4 plus 5 plus 3. 5 plus 3 is 8, minus 4 gives me 4. So now I need to find my slope, and remember that's my derivative, so f prime of x is equal to, well the 3 comes down, it gives me a 12x squared. And if I have a negative 5x, the derivative of that is negative 5, and the derivative of 3 is 0. So my derivative is 12x squared minus 5, and I'm going to find my derivative at negative 1. So 12 times a negative 1 squared minus 5. or 12 minus 5, which gives me 7. So when I come over here, y minus y1 is equal to m times x minus x1. Well, sorry, not plus, our y was 4, so y minus 4 is equal to, well, my slope is 7 times x minus a negative 1 is plus 1 over here. But notice all my answer choices are y equals, so we need to go through and solve for y. So y minus 4 is equal to 7x plus 7, and then I'm going to add 4 to both sides. So y is equal to 7x plus, well, 7 plus 4 is 11. So 7x plus 11 is C right here. All right, example 5. If the line tangent to the graph of the function f at the point 1, 7 passes through the point -2, -2, then f prime of 1 is, well, remember f prime of 1 is my slope at 1, or specifically the slope of my tangent line. Well, if I have 2 points on that line, I can find my slope. y2 minus y1 over x2 minus x1. So let's say that this is, let's do our negatives second. So I'm going to do 7 minus a negative 2 is plus 2 over 1 minus a negative 2 is plus 2. So 7 plus 2 is 9, 1 plus 2 is 3, and 9 over 3 is 3. So my answer is C. Ooh, let me circle that where it doesn't cover up the number. There we go. All right, number 6. If f of x is this equation right here, find the equation tangent to the curve at x equals 4. So I know that my x1 is going to be 4. I need to find my y1. So that's when I plug 4 in. So a negative 4 squared plus 12. So a negative 16 plus 12, which is going to give me a negative 4. So my y1 is equal to my negative 4, x1 is equal to 4, and I need to find my m, or my slope of my tangent line, which is my derivative. So f prime of x, well, the 2 is going to come down, negative 2x, and the derivative of 12 is just 0. So my derivative is just negative 2x. So my derivative specifically at 4 is negative 2 times 4, which gives me a negative 8. So putting all of that into my y minus y1 is equal to m times x minus x1. I'm going to have y minus the negative 4, so y plus 4 is equal to a negative 8 times x minus 4. And there's my equation for my tangent line that's tangent to the curve at x equals 4. All right, number 7, find the slope of the tangent line to the graph of, well, here's my f of x, at the point where x is equal to 1. So what I'm going to do right here is find my derivative and plug in 1. So I have a 2x times 2x squared minus 1. So this means that I need to use my product rule. So when I'm looking for f prime of x, I'm going to do the first 2x times the derivative of the second. So the 2 comes down and it becomes 4x minus 1 just goes away. Plus the derivative of the first, which is 2, times the second, 2x squared minus 1. And I'm looking specifically at 1, so I'm going to go ahead and plug in 1. So 2 times 1 is 2, 4 times 1 is 4, plus 2 times, well, 2 times 1 squared is just 2 minus 1, which gives me 1. So 2 times 4 is 8, plus 2 times 1 is 2, so my answer is 8 plus 2, which is 10. And it just asked for the slope. It didn't ask for the whole equation, so we're done. Make sure you're paying attention to what it's asking for. And let's look at 8. It says, given this function, for what value or values of x does the function have one or more vertical tangent lines? So remember, a vertical tangent line has an undefined slope. So that means that I'm looking for where the denominator is equal to 0 when I take my derivative. So first thing I'm going to do is rewrite my original function. And so I'm going to rewrite this as f of x is equal to x to the 1/2 minus 1. So now when I take my derivative, I have 1/2 times x. Well, 1/2 minus 1 is a negative 1/2. So my derivative is equal to 1 over 2 square root of x. So I'm going to take that denominator, 2 square root of x, and set it equal to 0. Divide both sides by 2, so the square root of x is equal to 0, and square both sides, so x is equal to 0. So the values of x where the function has a vertical tangent line is that x is equal to 0. It's only 1. All right, number 9, write the equation of the line tangent to the graph at the point -1, 1. So this one's nice because it tells me my x1 and my y1. So all I need to do is find my slope. So I need to find y prime, and I have to use my quotient rule. Everyone's favorite. So low, 2x minus 3. D high is 3. Minus high, 3x minus 2. D low, 2. All over low, 2x minus 3 squared. And let's go ahead and plug in that -1 for our x. So I'm going to have 2 times -1, which is a -2 minus 3 times 3, minus 3 times a -1 is a -3 minus 2 times 2, all over 2 times -1 is a -2 minus 3 squared. So -5 times 3 is a -15, minus a -5 times 2 is a -10. All over, well, -2 and -3 is -5 squared, which gives me a positive 25. So a -15 plus 10 gives me -5 over 25, which gives me -1/5. So there's my m. I've got my x1, y1. So when I'm looking for y minus y1 is equal to m times x minus x1, I'm going to have y minus 1 is equal to a -1/5 x plus 1, because minus a -1 gives me a plus 1. And for the last couple problems, we are going to look at this table over here to help us out. So it says, use the table to answer the following questions. The table gives values for f, f prime, g, and g prime at selected values of x. So 10 says, write the equation of the tangent line to the function f of x at x equals 2. So I need my x1, which I have. I need my y1, which is going to be f of 2. Well, if x is 2, f of 2 is -5. And I need my slope, which is my f prime of 2. Well, f prime of 2 is equal to 6. So y minus the -5 gives me plus 5 is equal to 6 times x minus 2. And there's my equation. So the table ones are actually kind of nice and easy. You don't have to do any of the find the derivative and plug the number in. It just gives you all the values you need. All right, 11. If h of x is equal to f of x times g of x, then what is h prime of 2? Well, if I have an f of x and a g of x, let's try that again, and a g of x, then I need to use my pen is not working very well. I need to use my product rule. So to find h prime of x, goodness. All right, let's see if the pen will work now. So h prime of x is equal to the first, so f of x, times the derivative of the second, so g prime of x, plus the derivative of the first, so f prime of x, times the second, so g of x. And I'm looking specifically for h prime of 2. So that means I'm looking at f of 2 times g prime of 2 plus f prime of 2 times g of 2. So f of 2 is -5 times g prime of 2 is 5 plus my f prime of 2 is 6 times g of 2 is 2. So I'm looking at a -25 plus 12, which is going to give me -13. And let's look at number 12 right here. Write the equation of the tangent line to the function h of x at x is equal to 2. So I need my x1, which is 2. I need my y1, which I don't know. And I need my slope, which we just found in number 11 to be -13. So to find my y1, well, I'm going to remember that h of x is f of x times g of x. So h of 2 is just equal to f of 2 times g of 2. Well, looking at my table, f of 2 is -5, g of 2 is 2. So -5 times 2 gives me -10. So let's put that all into our point slope form. So y minus y1, so y plus 10 is equal to m, so -13, times x minus x1, which is going to be 2. All right, that is all for this set of notes. Please make sure that you do your Go formative, and please make sure that you do all of the previous Go formatives that are past due now. And you guys have a good day.